Alright, so this is a suggestion via Patreon. The name of the video is 3 minutes ago, Voyager 1 just turned back and made a terrifying discovery. I'm sure it wasn't 3 minutes ago, like as in 3 minutes ago, but either way, I have no idea how old the video is, but let's check it out.
Get ready for an interstellar shocker that's bound to leave you on the edge of your seat.
Let's go.
Imagine launching a spacecraft 45 years ago, only to have it continue exploring regions never meant to be ventured into, long after its expected lifespan. That's the mind-bending reality of a daring NASA mission that's rewriting the rules of space exploration.
All right, really quickly. So I follow James Webb, basically, a whole lot. I don't know much about Voyager 1, but I do know that it is far out there, guys. Does Voyager 1 have the ability to send back any type of like visual data? That's a serious question, guys. Let me know in the comments.
But here's the kicker. This intrepid spacecraft is not only billions of miles away from its launch pad, but it's also sending data back to Earth using technology that's more outdated than a vintage cassette player. Talk about a shocker, but that's not all. NASA's groundbreaking mission, launched in 1977, has just revealed a spine-tingling discovery that has set the scientific community abuzz and captured the attention of the entire world. What could this horrifying finding from the last frontier be, and what does it mean for us all back on Earth?
Yeah, why exactly is it horrifying, guys?
And unlock the secrets of the cosmos. It was a moment in history when the stars aligned, and two of the most awe-inspiring spacecrafts ever launched into space took flight. It was 1965, the dawn of the space exploration era, and Gary Flandro, a brilliant mind at NASA's Jet Propulsion Laboratory, had a monumental task: to plot the optimal path for a space probe to reach the distant giants of our solar system, Jupiter, Saturn, Uranus, and Neptune. Armed with nothing but...
Bro, just go ahead and say Uranus, all right? Please.
But a pencil, a beloved precision tool of engineers in the 20th century, Flandro made a jaw-dropping discovery. He realized that in the late 1970s and early 1980s, all four gas giants would align in a cosmic dance, forming a celestial necklace with Earth. This once-in-a-lifetime phenomenon meant that a spacecraft passing by each planet could gain a speed boost from their gravitational pull, like being pulled along by an invisible rope. Flandro calculated that a journey from Earth to Neptune, which would have taken 30 years, could now be accomplished in just 12 years, thanks to these gravity assists. There was just one catch. This alignment only happens once every 176 years. Not one to miss out on such an extraordinary opportunity, NASA swiftly sprang into action. Within a mere 15 days of each other, they launched two identical spacecraft named Voyager 1 and Voyager 2 in the summer of 1977, aiming to make the most of this cosmic alignment. Little did they know that these twin explorers would go on to shatter all records in the history of space missions. More than 45 years later, Voyager 1 and Voyager 2 are still going strong, sending back groundbreaking information from the farthest reaches of our solar system on a daily basis.
Okay, but what exactly, bro, you're not telling us what you're sending back. Yes, we understand they were sent up, both of them, Voyager 1, Voyager 2. They're trying to reach the gas giants. Yes, but what type of data is Voyager 1 sending back to us? I think that's what us as the viewers are waiting for. Just pointing that out.
They have outlasted any other spacecraft in history and traveled further than anyone could ever have imagined. Quite a remarkable feat, considering that their original mission duration was only intended to be 4 years. But these interstellar pioneers had a few surprises up their sleeves. Early on in their epic journeys, they provided astonishing up-close views of the moons of Jupiter and Saturn, revealing a world far more dynamic and active than anyone ever anticipated.
Okay, so we're definitely getting visual data back. Great.
In their epic journeys, they provided astonishing up-close views of the moons of Jupiter and Saturn, revealing a world far more dynamic and active than anyone ever anticipated. With their discoveries of active volcanoes and fissured ice fields, the Voyager spacecraft defied expectations and forever changed our understanding of these distant realms. Voyager 2 blazed a trail through the cosmos, becoming the first spacecraft to venture close to Uranus in 1986 and then soar past Neptune just 3 years later. It stands alone as the sole spacecraft to have embarked on such a journey so far.
Okay, so I'm looking really quickly at some of the images that Voyager 1 had taken. They're solid. I mean, so whatever the imaging technology that's on that very specific thing, it's actually pretty good. Like, I mean, the overall fidelity of the images are much better than, honestly, I would have expected. 1965, 1977. Yeah, that's absolutely crazy, guys.
Surprising physicists with astonishing discoveries in uncharted territory over 14 billion.
Because, guys, really quickly, like, if you didn't know, we really can't photograph planets. I mean, we can photograph like the shape of them, but we really can't photograph them because we're not close enough for it, basically. Like, the only real way to photograph an actual planet, like via like astrophotography, is to use some type of like CCD or maybe CMOS camera, maybe, that is very specifically like tuned mainly for infrared purposes, and then use it to capture video, right? And that's it. And you just basically are going to pick the best frame out of that very specific video, and then you're going to call it a photo. But the images that are taken from this Voyager 1 are definitely not doing that. It's literally just taking a photo. It is that close to these planets, guys.
Miles from
spectacular.
Home. These pioneering interstellar probes, no larger than a vintage Volkswagen Beetle, have defied expectations and continue to push the boundaries of our understanding. The Voyager's epic journey began with a gravity assist from Venus, a maneuver never before attempted by spacecraft on their way to Mercury, making them true trailblazers. But it wasn't an easy feat, with margins of error measured in tens of minutes and multiple attempts to get it right. The first leg of their voyage to Jupiter took them to a distance 10 times farther from Earth than Mercury, and they had to navigate through the treacherous asteroid belt, a topic of much debate and speculation beforehand.
Yeah, how did that exactly happen? Hold on, wait. If it's taking 10 minutes to communicate with this device, how exactly are you getting through to any of this? Like, how are you able to maneuver through an asteroid field if it takes 10 minutes to communicate with it? Unless they had some type of AI back in the 60s and 70s. I mean, that could be a thing. I don't think so, right? At least. But again, amazing to hear, I guess. But yeah, there has to be some type of AI, maybe, or something.
Pioneer 10 and 11 blazed a path.
Unless they'd be able to map it. Also, that could be it. Also, like if they mapped this asteroid field, which I don't know how, if this is the furthest we've been, and it's the first time, guys. So many questions.
Through the supposedly dense asteroid belt unscathed, paving the way for Voyager. But Voyager's challenges didn't end there. With only 69 kilobytes of memory, equivalent to a fraction of a smartphone's capacity, the Voyager computers had to rely on onboard intelligence to manage the complexities of their journey.
Okay.
The data gathered by the instruments on board was stored on 8-track tape recorders before being transmitted back to Earth by a modest 23-watt transmitter, about as powerful as a refrigerator light bulb. Equipped with 12 feet wide dish antennas, the Voyagers used radio communication traveling at the speed of light to send and receive messages, but their immense distance from Earth, advancing by 3 or 4 light seconds every day, presented challenges in staying connected. The signals from Voyager 2 took over 18 hours to catch up, and the growing interference from Earth's noise, including radios, televisions, cell phones, and more, made it increasingly difficult to hear the faint whispers from the spacecraft. Yet despite these obstacles, the Voyagers have defied the odds and continue to surprise astronomers with unexpected discoveries in the interstellar void. Their journey has rewritten our cosmic playbook and altered our understanding of the unknown realms of space. Far beyond our solar system lies the enigmatic Oort cloud, a celestial gathering of comet-like entities bound together by the sun's gravitational pull. Stretching halfway towards the nearest star, it remains a distant realm that the Voyagers are slowly but steadily making their way towards. However, interstellar space, where the solar wind phenomena give way, is a more accessible frontier. It's where the heliopause, the border between our solar system and the interstellar space, marks the beginning of uncharted territory. Initially, estimates of the heliopause's distance before the Voyager probes reached it were inconsistent, but assuming it to be around 50 astronomical units, AU, the mission's funding was increased. Yet, as the spacecraft departed from this landmark, no expected signs of interstellar transit were detected, leaving scientists perplexed. One of the anticipated indicators of crossing into interstellar space was an abrupt increase in galactic cosmic rays, high-energy particles expelled from supernovae and other cosmic cataclysms at nearly the speed of light. However, most low-energy cosmic rays are deflected by the massive magnetic shield created by the heliosphere, which protects our inner solar system from the majority of external threats. The Voyager team was also keeping a close eye on any changes in the dominant magnetic field as the spacecraft ventured further. The interstellar medium, composed of ionized gases and influenced by nearby stars, was expected to have a different magnetic field orientation compared to the heliosphere. Yet the Voyagers reported no such alterations, adding to the mystery. It was on August 25, 2012, when Voyager 1 finally crossed the heliopause and transmitted back intriguing data.
Okay.
While it did confirm the expected increase in plasma density, there was no indication of a shift in the ambient magnetic field's direction. This was unexpected, as it was assumed that a change in magnetic field direction would occur when transitioning from a region where the Sun's magnetic field prevailed to one influenced by other stars. In November 2018, Voyager 2 embarked on an extraordinary journey to the interstellar seashore, arriving at the heliopause, the border of our solar system, 120 astronomical units AU from Earth, the same distance reached by its twin 6 years prior. But what puzzled scientists was that Voyager 2 detected no changes in the magnetic field as per the theoretical models, adding yet another enigma to the mix. According to predictions, the heliosphere, influenced by the Sun's 11-year cycle, should have ebbed and flowed, just like the solar wind. However, none of the existing models could explain this discrepancy, as the solar wind was at its strongest when Voyager 2 arrived, suggesting that the heliopause should have been farther out than 120 AU. As the Voyager probes venture closer to the interstellar medium, their data reveals intriguing small-scale changes near the heliopause, influenced by the heliosphere's interactions. Yet at vast scales, the magnetic field shows negligible variation. This raises questions about whether the spacecraft will eventually leave these turbulent shores behind and encounter the true interstellar magnetic field, or if the current understanding of the simulation is entirely off the mark. Some academics speculate that the Voyagers may still be within the heliosphere, while others are convinced by the significant increase in galactic cosmic rays and plasma density detected by the probes, pointing towards the majority opinion. Solving one of the most fundamental puzzles about the heliosphere is akin to trying to see a goldfish bowl from the perspective of the fish. We need an interstellar probe to shed light on it from the outside. However, while some technologies like answering machines, VCRs, and pennies have become obsolete, the Voyagers continue to defy the odds with their outdated yet resilient systems. These spacecraft
all that does is speak about,
from
exactly how much effort people put into building an absolutely solid device back in the day, right? Before we had to basically, fight for a right to repair and things like that, right? People definitely put more effort into building things correctly a much long time ago. So of course it's still a functional device in space, because again, even though the technology is completely gone, the fact that this large device has less than 30 kilobytes of data ability, that's that's crazy, but it works. That's it. But here's the thing, guys. I'm trying to figure out what guys, hold on. The title is 3 minutes ago, Voyager 1 just turned back and made a terrifying discovery. I want to know what the terrifying discovery was, guys. After leaving our universe, but it's not, the heliopause, I think is what he called it. Never heard this word in my life, guys. I'm pretty much a space junkie a little bit, guys. I've never heard this term before, though. But after leaving that, then realizing that there was still no real change in the magnetics. I mean, I get how that could be something interesting, but I don't see that as being a terrifying discovery for the reason Voyager 1 would be turning back. Why is Voyager 1 turning back, and what was the terrifying discovery?
50 years ago, with minimal software to operate them, and their designers couldn't rely on complex lines of code. Voyager 2 currently has 5 operational instruments, while Voyager 1 has 4, all powered by a mechanism that converts heat from plutonium's radioactive decay into electricity. But NASA has had to resort to a triage mode as the power output of the Voyagers diminishes by approximately 4 watts every year. 3 years ago, the mission's engineers had to shut off the heater for the cosmic ray detector, a crucial instrument for determining the heliopause transit. Despite everyone's expectation of its failure, the instrument kept functioning, even in extreme temperatures that were well beyond its tested limits, a truly astounding feat. The magnetometer and the plasma science instrument are expected to be the last instruments to shut down, as they are located inside the spacecraft's main body, warmed by the heat produced by the computers, while the other instruments are mounted on a 43-foot-long fiberglass boom. What lies ahead for the Voyagers? If all goes according to plan, scientists might be able to extend their missions until 2030, but the real game changer is power. It's the determining factor, even though the Voyagers will keep forging ahead, undeterred by challenges. In a mind-boggling timeframe of 16,700 years, Voyager 1 will pass by Proxima Centauri, our closest neighbouring star. Voyager 2 will follow suit 3,600 years later. After that, they will continue to orbit the galaxy for millions of years, long after our sun has faded away and the heliosphere has vanished. These resilient spacecrafts will still be there, largely intact, unlike our tiny blue planet. Perhaps they may even deliver a final message at some point during their endless journey. However, it won't be transmitted over the radio, and if it is, there won't be any humans. The Voyager's saga continues to be a testament to human exploration and scientific curiosity, defying the limits of time and space. All right. Now let's hear your thoughts on the Voyagers in the comments below.
Okay, listen. Okay, this is a little frustrating, just a tad bit here. The title is wild. It doesn't really make any sense for what we just watched, guys. I'm thoroughly invested in kind of finding out exactly what's going on with Voyager 1 and Voyager 2 now, because now I have to know. And it takes photos. Oh, yeah, I'm interested, right? But we're probably going to, guys, the channel's name is like Cosmos something. No offense. Do your thing. But I would rather you guys send me things that are like more informative. Because I don't think I've learned too much here, guys. But either way, listen, you guys all have an absolutely amazing day and enjoy your day thoroughly.